Here are two vectors A and B. We'll assume they are vectors of the same type, say both forces or both displacements, for example. They act in different directions. You can see that vector A has approximately twice the magnitude of B. Remember, the magnitude of a vector is denoted by the length of its arrow. We can add these vectors together, and there are two useful ways to visualise doing so, the tip-to-tail method and the parallelogram method. In the tip-to-tail method, we pick up one of the vectors and put its tail on the tip of the other. Then replace the two arrows in sequence with a single arrow. That single arrow is the composite vector A plus B. In the parallelogram method, we begin with the two initial vectors A and B starting from the same point. We then create a parallelogram using the two vectors as two sides. The sum of the vectors is then the diagonal of the parallelogram. These two methods for adding vectors are functionally identical, but there might be situations in which it helps you to visualise one of the methods or the other. If the vectors are displacement vectors, where one displacement follows another, then the tip-to-tail method can help you to visualise a trajectory. When forces act at a point, the parallelogram may be more intuitive. For example, if this ship were pulled by two tugboats, then the diagonal of the parallelogram would show the direction of the resultant force on the ship. Next, let's ask what are the possible magnitudes of the vector sum A plus B. At first sight, this may sound like an odd question. After all, adding two scalars has only one answer. For example, 2 kilograms plus 1 kilogram is 3 kilograms. But when the directions of quantities being added can vary, that is, we're adding vectors, then the sum can take on different values. For example, let's imagine that the vectors A and B are in the same direction. Then the magnitude, denoted with these vertical modulus signs of A plus B, is equal to the sum of the individual magnitudes. This is the maximum value that the magnitude of A plus B can have. If B is in the opposite direction to A, then the magnitude of A plus B is equal to the difference in the magnitudes of A and B, and this is the smallest possible magnitude of A plus B. And if A and B are at some angle other than 0 or 180 degrees, then the resultant vector has a magnitude in between the minimum and maximum values just described. Finally, just to reiterate this point, here is vector A with B added to it in the three orientations for B that we have seen so far. But B could conceivably point in any direction. Then it describes a circle around the tip of vector A, and the composite vector A plus B could be any of these black arrows that end on that circle, plus an infinite number of others besides.